move on to vertex form, which is the same idea and the same concepts, just a little bit different. So if you remember, vertex form is the one that we used. Now we're going to be focusing on finding that a value in front, okay? So it says given the vertex is at -3, -4, which really means it went left 3 and down 4, write a possible equation. We want to ignore the fact that it has a stretch factor, so we can write that a there if we want, but we don't have to for right now. It's going to be x plus 3, because remember, if it went left, it's really a plus, and then it went down 4. And then it says graph. Lucky me, I already have my graph down here. Now, if you were going to graph on your paper, you're just going to go to the point -3, -4, and plot that point. And then I can just show you the x-intercepts are at -1 and -5. You are not able to find that just given the equation. So it says, what are the x-intercepts? -5 and -1. And the axis of symmetry, remember, is just the x-coordinates, so it's just x equals -3 because the x-coordinate of my vertex is at -3, right? Now we have to remember, well, what does that a value do even if it's in vertex form? So all of these have the same vertex of 3, 1, because remember that means right 3, so it's going right 3, up 1. So there's my vertex for all of them. Now the first one has a 2 in front, so that means I'm really going up 2 over 1, up 2 over 1. That means this one's going to be narrower. And this one has a negative in front. That means it's just going to be opening. Whoopsie, my calibration's really off a little bit. That just means it's going to be opening down. And this last one has a 0.25, which is really just 1/4. That's going to be opening down, and it's going to be much wider. It's down 1/4 and over 1. My calibration's really off. So my U is going to be much wider. So the purpose of this is not for me to be neat. I apologize, it's a little messy. The purpose is to show you that all 3 of these equations have the same vertex, but they all have completely different shapes dependent on what number is in front, that a value. So we need to learn how to solve for that a value. So it says, write an equation with a vertex of 2, 2, and also goes to the point 1, 6. Notice I've changed up our format here because we're now writing it in vertex form, which if you remember is right up here. Y equals a, which is just our stretch factor, x minus h squared plus k. Remember, inside is opposite. It goes left, right. Outside is actually up or down. Okay, so I'm going to write y equals a parenthesis x minus 2 because it's really a positive 2, which means it went right 2, and it also went up 2. All right, so I'm going to rewrite that equation, y equals a times, that's the vertex form of this equation. It went right 2 and it went up 2. So basically what I have going on right now is I went right 2 and up 2. That is my vertex. And I can also point out right now that the axis of symmetry is going right through there at x equals 2. That's my axis of symmetry. All right, so next step, take the point they give me, which is 1, 6, and replace y with 6, and replace x with 1. So now I just solve. So I get 6 equals a. 1 minus 2 is -1. Now what I always do is I always move this 2 over because then I can get rid of it. I cannot add it to this part because there's an a attached to it. So always move that extra number over first. So I get 4 equals a times -1 squared. Well, how nice for me, -1 squared is really just 1. So I can divide by 1 if I want and see that a equals 4. Which means graphically, this graph is much narrower. So if I go to write my final equation, right, like this one up here, my final equation is going to be y equals 4 times x minus 2 squared plus 2. Which means this is going to be pretty narrow. If we graph the point 1, 6, we can already see that this parabola is getting pretty... Excuse my poor drawing. You can already see that this parabola is getting pretty narrow. Remember, there's going to be a matching point over here. So when it says use symmetry to name another point, all you need to do is go across your axis of symmetry. So it's 1 away. So I count 1 away on the other side to get my, oh my gosh, my drawing is really terrible today. Apologize. My other half is right there, and that's the point 3, 6. And that's how I can make an accurate sketch of that parabola without doing too much. All right, so what I want you to do is my last example. I want you to pause the video and see if you can get through this one all on your own. And it's really example 2, I guess, but we did one earlier that we called example 1. All right, so vertex at -3, -8, which really means it went left 3. So I get a +3 on the inside, and it went down 8. So I'm going to write -8. All right, and it has a y-intercept of 10. Remember, the x-coordinate of every y-intercept is 0. So when you see the word y-intercept, you really just want to write a 0 in front of it every time because it's really the point 0, 10. And that's important because I need an x and a y to plug in. So I'm going to rewrite my equation. Y equals a times x plus 3 squared minus 8. All right, and I'm going to plot on my graph what I know. I know that it has the vertex of -3. Oops. Go down farther. -3, -1, 2, 3, -3, -8. And I know it has a y-intercept of 10. Wow, that's big. 9, 10. So you can quickly see, wow, I'm going to use my straight edge. My axis of symmetry is right here. My other point is way up here. So you can quickly see that this U is going to be very, very narrow. Wow, that is just horrendous. There's half of my parabola. Okay, now to get the other half, I'm just going to go across the axis of symmetry. So it's 1, 2, 3 units away on this side. I'm going to go 3 on this side. 1, 2, 3. And there's my matching point, and I can draw the other half of my cruddy U. Wow, it's really bad. Anyway, I got the next point, so that point is point 1, 2, 3, 4, 5, 6. -6, 10, because this point is up here at 10. And so when I go to solve, I'm already expecting this to be a big number because it's really, really narrow. Okay, so I'm going to take my equation, and I'm going to replace y with 10. And I'm going to replace the x-coordinate with 0. All right, so I get 10 equals a times 3 squared minus 8. Again, always get rid of this number by moving it to the other side. So I get 18 equals a times 3 squared, which is 9. And it's attached by multiplication, so I'm going to divide. So I get a equals 2, which makes sense because my parabola is pretty narrow, so it's got to be a number bigger than 1. So to write my final equation, I go back up here and I see that it's y equals, I now know the a value is 2. Whoopsie, ignore that last little thing I wrote on there. So my final equation for this is y equals 2 times x plus 3 squared minus 8. It went left 2, down 8. Again, to get that other point, you're always just going to go across the axis of symmetry and match it, and you're going to draw a much nicer U, but my thing's not working out very well. All right, go ahead and do the on your own, and I will see you tomorrow.